Hello guys, my name is Daniel Fernandez. I'm the owner of scienceinhydroponics.com, and today we are going to figure out whether this freaking fertilizer has the amount of nitrogen that they say it does using a Horiba nitrate probe. Not sponsored by Horiba, although I'm open to it. If you're seeing this, Horiba. So, in order to do this, I'm going to first show you the calculations that you need to do in order to figure out how many ppms of nitrogen you would expect to read with the Horiba ion selective electrode probe. And then we're going to prepare the solution using a syringe and a 250 milliliter Class A volumetric flask, which will give us an accurately prepared solution. So join me in the preparation of this solution, and will we get a result that matches, won't we? Stay tuned. Okay, so let's do this pretty quickly. We have a fertilizer that has a given amount of nitrogen, and this time the fertilizer has 4%. It's a liquid fertilizer that I purchased, so it is 4% nitrogen, and this is weight by volume. So what does this mean? So this means that we have 4 grams of fertilizer for every 100 milliliters of the fertilizer, right? Because it's the percentage of the solid in the liquid. So for every 100 milliliters of solution, you add 4 grams of nitrogen as nitrate, which is what we want to detect. Now, the application rate for this fertilizer, the application rate is 4 milliliters per liter of final solution you want to prepare. So let's figure out how much nitrogen in ppms we get whenever we do this application rate. So nitrogen in ppms. So we are going to add 4 milliliters per liter. And then we're going to multiply this by the composition, which is 4 grams per every 100 milliliters of concentrated solution we add. And then we're going to convert this into milligrams, because parts per million is milligrams per liter. So 1000 milligrams in 1 gram. And then you can see here milliliters goes with milliliters, grams goes with grams, and we can cancel here this 100 factor with this one, and we are left with 4 times 4, 16, times 10, 160 milligrams per liter, which is equal to 160 ppms. Now, we are going to make a preparation for 250 milliliters. So we're going to prepare 250 milliliters of final solution. So how much do we need to add? Well, we have 250 milliliters of final solution, which I'm going to call FS. And we know that we need to add 4 milliliters of fertilizer for every 1000 milliliters of final solution, because that's the application rate. And that's equal to basically 250 times 4 is 1000 divided by 1000 is 1. So basically we need to add 1 milliliter in 250 milliliters. That's the application rate. So if we add 1 milliliter to 200, if we add 1 milliliter and the final volume of the solution is 250 milliliters, then we expect to have 160 ppms. However, guys, it is worth noting that the Horiba probe does not measure ppms of nitrogen as nitrate. It actually measures ppms of nitrate itself. So we need to convert these into nitrogen ppm, so ppms of nitrogen as nitrate, and that can be done simply by, this is equal to the nitrate ppms that we measure with the Horiba probe times 0.22. So we need to multiply the reading that we get from the Horiba probe by 0.22. The Horiba probe can also be configured to measure this, but bear in mind that the default measurement is this. Okay, let's make the measurement and find out. Okay, back to the experimental section. We are going to prepare the solution, for which we are going to add 1 milliliter of this 4% nitrogen fertilizer into a volumetric flask and then take it to final volume. For the volume addition, I'm going to use a syringe that allows me to do this with enough precision. So first of all, I'm going to purge the syringe with the fertilizer. Now I am going to purge the volumetric flask, because we're not savages, so always purge your volumetric material with distilled water. And now I am going to measure 1 milliliter with the syringe. Make sure you always cap syringes after you use them. Don't want to end up stabbing yourself with fertilizer. And now I am going to take this to final volume. One, two, and three. And this is now homogenized. And now let's bring in our protagonist, the Horiba probe. So first of all, I am going to purge it with the fertilizer we just prepared, with the final fertilizer solution. So the probe has been previously calibrated, so make sure you calibrate it. I made a video about how to calibrate these Horiba probes in my unboxing of a potassium probe, but make sure it's calibrated before you measure. So just purge several times. We're gonna leave a little bit too much. So you just want to leave enough to cover the sensor, close it, and now I'm going to turn this on. And it gives us a reading of 590, as you can see here. And now I need to convert this, because I'm not that good at math. I'm actually terrible at arithmetic. Like living in the US, calculating tips was such a nightmare for me. And this is 129 129.8, so let's say 130 ppms. And we were supposed to get 160, so we have probably 10 to 15% less nitrogen than what we thought we would have. However, the Horiba Pros have a precision of only 10%, an accuracy of only 10%, sorry. So in order to ensure that we get a good reading, I am going to repeat the measurement so that we're more certain about the measurement beyond the precision of the instrument. So I'm gonna purge again so that anything that was there will be gone, and then we will repeat the measurement and see what we get. So as you can see, smiley face, 590. So our measurement was correct. We have 130 ppms. So this is plus or minus 10 ppms here on nitrate. So this means that we have around plus or minus 2.5 ppms in the actual nitrogen measurement that we calculated before. So this is actually way below what we expected, which means that the fertilizer has less than what it says on the label. So the fertilizer people are scamming us a little bit for this, for this fertilizer. Now I'm going to repeat the measurement a third time so that we can be fairly sure. So I'm going to and repeat the measurement for a third time, exactly the same measurement, so we're pretty sure it's 590 ppms of nitrogen as nitrate. Hydroponic solutions do contain a lot of ions, but that can interfere with readings a little bit, but the sensitivity of the Horiba probes is high enough that this interference is not expected to be large given the composition of a hydroponic nutrient solution for the detection of nitrate. Therefore, we can be pretty sure that this fertilizer has around 10% less nitrogen than what they're telling us on the label. Now, this is a great tool, and not only to see if you're getting the amount of nitrogen that they're telling you, but it is also a good tool to follow the amount of nitrogen in a recirculating solution and figure out how your nitrogen is changing as a function of time. Now, after you carry out the reading with your Horiba probe, you want to wash it with distilled water. So wash it a couple of times with distilled water, and then we want to gently tap it with a paper towel so that we remove any moisture, because these are supposed to be stored in a dry condition. So now this is dry and you can store it. We can switch it off by there, and then we store the Horiba probe. Okay guys, so we calculated how much nitrogen this was supposed to give us in the solution as specified by the manufacturer, and we actually found out using the Horiba probe that this is below what we're supposed to get. Now, this is not uncommon. It doesn't mean that they're scamming us. It means that they are likely having high errors in their preparation. They are likely not measuring volumes as precisely as they should, as accurately as they should, which is very common in the fertilizer industry and can lead to these sort of issues. If you have one of these probes or some of the others, like the potassium or the calcium probes, you can actually use them to verify what you're getting across different batches of the fertilizers that you buy or the fertilizers you prepare yourself. That way you can see what the errors are, and you can be sure that you are within the error that these can give you. And that way you're at least sure that you are accurate enough, like at least within 10% of your actual targets. So thank you very much for watching this video, and please make sure to share, like, and subscribe. Please share, please. Beg you, share. If you find this interesting, feel free to suggest other topics on the comment section. I'll be happy to oblige to some of your suggestions. Thank you very much for watching this video again. See you on the next one. Bye bye.